Hello, am I audible?
Yes,
Yes,
sir,
sir.
you're audible, sir. Yes,
You're
sir.
audible. Just 1 minute, Arun, we'll start.
Sure.
Uh, Good evening, all. I welcome you all for the second day of our industry oriented FDP on the power of AI in industry, automating AI development and ensuring its practices. In this occasion, I would like to welcome our resource person, Mr. Arun Pandian. Welcome, Mr. Arun. Thank you for spending your valuable time with us today for this wonderful session. I request all the participants to make use of the session. Just mute yourself till the session gets over. At the end of the session, if there is any doubts, you can unmute yourself and you can clear your doubts. And similarly, at the end of the session, feedback link will be shared with everyone. So please fill it on or before 8:30 p.m. on the same day itself, and it will be considered for your attendance also. Now, I request Dr. Vamsi to give the introduction talk about Mr. Arun Pandian. Sir, please, sir.
Yes, ma'am. Thank you, ma'am. Good evening to all the participants. We are honored to welcome Mr. Arun Pandian R, a highly skilled data professional, research engineer, and extreme level coder, currently working at Siemens Bangalore in the R&D division. With over 7 years of experience in AI, deep learning, data engineering, and full stack development applications, he has been at the forefront of AI-driven innovation. In his role at Siemens, he is responsible for developing an application called Data Lake House. It is a cutting-edge industrial data storage solution that optimizes business operations through business intelligence and AI/ML applications. Prior to this, as a technical team lead at QPI Cloud, he led the development of anomaly detection algorithms for data center management, ensuring robust enterprise AI solutions. Beyond industry, Mr. Arun has published three SCI indexed journals in international journals. His research spans includes applied machine learning, deep CNN, computer vision augmentation, structural engineering, and smart building design. Arun is also a recognized competitive coder, winning multiple hackathons, including Smart India Hackathon and Manipal Biotech Hackathon. His academic project, COVID X Detector, a deep learning based system for COVID radiography diagnosis, received widespread recognition. A passionate speaker, he has delivered guest lectures, technical seminars, and even TEDx talks at leading universities. His combination of industry, enterprise, research excellence, and hands on coding skills makes him a standout AI professional and mentor. We're delighted to have Mr. Arun Pandian R with us today. Let us extend a warm welcome as he shares his knowledge on automating AI development with domain fine tuning. Now, without any further delay, I hand over the session to you, sir. Now, over to you, sir. Thank you.
Thank you, sir, for a very warm introduction and welcome. Thank you, ma'am, for all the invitation and felicitating this event. And yeah, I thank the institution for calling me here, letting me share the knowledge. And yeah, let me start my session. Let me share my screen. Just give me a moment. Please let me know if you see any sort of disturbance during the session.
Sure, sir.
Please do raise it promptly.
Your screen
Yeah.
is visible, sir. Yes.
Thank you, sir. So during the session, if any troubles means, please raise me immediately. Cool. Yeah, let's start off with that. So I myself, Varun Pandian, as I mentioned, so I've been working on this AI and data domain for the last 4 years. So during my time, I've seen a lot of evolution, as you might also know, following up the news and following up the trend in the industry. This AI has been the primary focal point of the software engineering industry or the entire IT technology industry as self. So in particular to AI, there has been so many research that has been happening, so many breakthroughs in transformer architecture, the LLMs, as you might know. These are all some scientific or very academician level AI research. But on top of that, what the this current age engineers and students are being very highly sought out for is the engineering side of it. So how to automate it, how to maintain all this AI infrastructures. That has been a talk of city for a while. So my today's topic is on automating this AI software or automating this AI development, modeling, and everything. So this primarily talks about the the technology that is MLOps, which is still at its newer level. So we are yet to see a lot of improvements. There are a lot of people that should be working in it. So today my agenda is to educate or give an overview about what machine learning or machine learning application development in the industry is being practiced, and what all the challenges that we faced if we are taking up a AML project, or if you are deploying any application for end user usage. What are all the challenges that we are facing, and how these challenges are being handled automatically. So this is being a very important case for all the industries and enterprise. They don't want to put in a lot of resource people in handling all this AI. It's always tricky since AI is also a black box. The guys at higher level doesn't really want to take a risk. So we will have to have a strict framework or a strict protocol that will almost prevent all these bad things from happening. So that protocol is inherently proposed by this MLOps practices. So let's first get started. What started with the conversation of what machine learning application means. So as general software application, we can all define the one we are currently in contact with now. Teams, Microsoft Teams is also a software application. It's a based application. So meaning with the help of internet, it is connecting you to everyone else. So it also has this video feature. It also has this screen sharing feature. The attendance, all the user interface that you see in this current application that you are in. So that is a software application which runs in a internet. So it is called as a web-based application or web application. So if we say that as a web application, what will machine learning application will be termed as? So we all know ChatGPT. If we call that a machine learning application, what else it can be a part of a machine learning application? So a machine learning application is also a software solution, just as anything. It is a subset of the any software application. It is being integrated with any particular machine learning model. Not only all the LLMs or not only many deep learning models, any sort of machine learning algorithm, be it may linear regression, everything can be a ML model, and this should be used to perform one specific task. And if that task is taken with the model based or statistic based decision, then it is termed as a machine learning application. So it also consists of every machine learning will also contains a UI. As the example I said, ChatGPT, it's not only the LLM model, it also contains that UI that we can access it or interact with, and it will also have the backend. ChatGPT, the OpenAI people will also run the API servers and everything, the REST framework or API server. So the traditional, and also it will have a database. All the previous history of chat that you made with ChatGPT, you can see it in the user interface. So storing all the data is not the job of ML model in any way. So that will be handled by our traditional database systems only. So so you can map out with this. A machine learning application will only, a part of a machine learning application will be a actual ML model, whereas the other side of part will be our traditional software application. So this is what is sets off apart from a traditional software and machine learning software, because with the use of the ML model integrated in it, it is telling us something. It is telling some decision to us. If we ask ChatGPT, it will tell us some answer or some prediction or something. So that prediction, that answer, that intuitiveness is being the job of the machine learning model. So that particular thing it is saying. So that's why we can call it as a ML engineering. So let's dive down to a very simpler example, which is this is in any industrial use case or academician's use case. This is the simple thing. So here our example is to build a machine learning application which can find out cracks in any surface. So this will be a information, or this will be a photograph of any surface. If there is a crack in that surface, we need to classify it and say is it no crack, good, or if there is any crack found, we are going to control that. So what all the components will be in this particular example? We will have two things. So one that will be in the cloud component, meaning uh, meaning that actual machine learning model will be in some other place. You will only send the data to it and receive what is it. So at, at your local or at your edge, you will have a quality check device. This can be a smartphone, this can be any IoT based device which will have one CPU and a camera. So the control application is the application that we can take photos with, that will operate the camera and it will take the photo with. And the same control application will send that taken image to the server in the cloud, and that server will process it will pass to the ML model and will get the prediction. So that prediction it will in turn throw back to the control application, and from the edge you can see it. So you can imagine this particular portion as you are consuming it in your mobile phone. You will consume it through some app. So the ones that you will have to very pay your focus into where the model is. So the model is only one thing. So we can actually multiple people can take the photo in their own edge device. Sorry, in their own edge device, and then they can use the same server to predict every or get the predictions of many other things. So this can be a drone, this can be a smartphone which will have a camera interface. This can take the photos of an entire surface around any sort of buildings or any road or something. So that can be processed by our so in this example, what are all the things that we need to take care of? So in any machine learning model, there can be two different types of model deployment. The one that we spoke of is defining or falling under the cloud deployment. As I said, multiple people can access the same server, and the model can be used to get prediction or throw prediction to multiple people. So in our initial example, ChatGPT is only one website, which is we are all using across the entire world. So the model will be at their side, all the processing, all the computation will be happening at their side at some server. And what we are getting is only the output of the model. So similarly, in our use case, we can throw the output of our model to multiple quality checks device. So this is almost a centralized manner. So most of the ML application currently is following this pattern, where you will
Thank you.
have your, sorry, hope you can hear me loud and clear. So got it. So let me continue. So this is a centralized architecture, meaning there will be a single cloud which will be having your ML model. So the maintenance of things will be at a single place. It will not be at a multiple place. So the problems like updating this model or rollback of this model will be similar. So whatever traditionally, whatever software related bugs that we face, that will also apply to an ML model also. In software, you will have to update your application. So if you got a mobile phone or mobile application, you will have to update that application every month, so that any security related issues or any little bugs can be rectified. So similarly, ML model will also need to keep on updating, so that if there is an issue, if there is any future challenges which we'll discuss later in the session, can be rectified. So what will be the opposite of this deployment step? It is edge-based deployment. So in edge-based deployment, the actual model and its pre-processing, all the steps will be in the quality check device itself, the edge device itself. So see this previously in our concept, uh, this was in the cloud, but now we have brought all the model and the pre-processing in the edge device itself. So this sort of ML application will be used in a much more lightweight machine learning model, which can run in any mobile phones or IoT devices as such. It doesn't need a centralized environment or centralized server, but it will have to be so small, and it will have to be compatible with any such device that we are running it. So this is called an edge deployment. But in this, what all the challenges will be? Now this will be in all the devices. So all the devices, everyone will have their own ML model. So pushing updates to the all the ML model and verify if everyone got the latest update is little difficult. Similar to our Android app application, so you might have updated your WhatsApp, but your friend or your colleague might not have updated your WhatsApp. So I'm sure you must have ran into the situation that there it might be saying to you, you'll have to update to send messages. So the same case will be applied to ML model as well, but it is a little bit trickier, because the consequences of ML uh, we will see what are the consequences of a ML models. So a challenges in ML deployment. Here, this is you can see in this example, we can straight away see that this surface is good, and we can straight away say that this surface is having a crack. But we will obviously, even as a humans, we will take a little time when we are classifying this. Obviously, it is having some sort of crack, but since the brightness or since the light is not enough, even as a humans, we will struggle to classify this, whether it is a good surface or a bad surface. So similar things, machine learning model will also go through. Since it's a computer vision problem, we will have all the camera related or vision related problems. So exposure, contrast, shutter speed, resolution, all this will contribute to a less par image that will feed into the ML model. So if the image is not good, the ML model's prediction will also not be of accurate. So this is what we call as a concept drift. So a concept drift is a relation between the input and the target variable that changes over time. So we already said this is the input for the model and this is going to be input for the model. We haven't shown the model. This might also come like this. So the input is changed a little bit. Now the input is less bright, and this is also called as a concept drift. And this also leads to a decrease in prediction accuracy, a sudden shift or a drift. So this can also happen suddenly. So in the example that I showed you here is a new regulation changes and that will change the behavior. So every year our government will have the budget or some government policy will apply. Immediately after that government policies, people's behavior or people's behavior in investing or their means of saving a asset will change. So some might go with buying a goods, and some might go with the policy change. Some might go and buy a lot of stocks. So our data model that has been trained on it will see a sudden shift in the behavior of the actual input data. This is to do with the financial machine learning assistance. And slow and gradual changes is customer preferences or music preferences. These sort of application with Amazon, with Myntra, all this fashion or e-commerce application, customers' preferences will change over time. It can be of 5 years or in 10 years, but it will slowly change to a newer fashion or to a newer trend. But ultimately, it will change, and our model will also need to be keep in update with all these changes. And there is a recurring drift also. So our weather prediction models will also need to take into account of time of the year. So over the year, we are having a seasonal changes, right? So this seasonal changes will also impact on the e-commerce sales. So they will have to better plan, or this ML mission will have to be updated, or we should choose which model to use in which season. Likewise, we'll have to plan. So all these are logistical nightmare. We will have to train model, we'll have to update model. So obviously there needs to be some tracking or some uh, base monitoring of all this model. So how we will monitor, how we will track, we will discuss later in the slide. Before that, let's get to the data drift. So this concept drift, as we already said, we are uh, we are talking about the data being changed over time, but or a concept of the data being changed over time. But this data drift is more explicit. This is the target or the output will be same thing, but uh, yeah. So in our previous example, the bad lighting or any input changes, the output will be the same, but the input is rather different. So concept drift is on the data being changing over time, data and the output being changing over time. The data drift is output being the same, but the data is being variant over the time. So this also may be confusing, but the data drift will be even more clear once we get to the actual challenges on the software engineering front. We can move on. So we'll have some lot of slides to cover before we get to the demo part. And yeah, so now what is our issues that we face in the industry with all this machine learning applications? Yeah, so deploying the machine learning applications, just like how we are giving update or pushing updates to all the Android or iOS application, mobile applications, we also have issues in ML models also, which is all. So this side of issues, which in terms of running the model, not in terms of conceptual understanding part, whatever that we discussed before. Now this is completely software engineering side. What are all the hardware requirements? Sometimes the machine learning model will not run in some people's devices, but it will run in other people's devices. So these are all points out to compute resource limitations, or it can be a model inference latency. So this you might have experienced with ChatGPT. Sometimes it will take 5 seconds, sometimes it will take 6 seconds to reply you. All those things, and logging is also a problem for us. Logging as in whatever model is doing, we'll have to monitor, keep on monitor it. If there is any problem in it, we'll have to look through it and find what is the root cause of that issue. And security and privacy concerns. So security of the model itself, nobody should steal or hack into our model, and also privacy concerns. So the data that I give you, you shouldn't share that to other people. If it is an LLM or if it's a traditional ML software, the data of mine should not be shared explicitly to others. So that is a data privacy concern. And real-time processing methodology or batch processing methodology, and cloud or edge. So this cloud or edge concept is what we discussed earlier in our session. And yeah, so going into we are all learning or taking specialization in AI or AIML modeling development. So we might have working in Jupyter notebook, trying to model some things, trying to create a machine learning model. But in the whole context, machine learning model is only occupies 5 to 10 percentage of the actual ML application. So in any ML application or in any industrial use case that we are working on in our industry, so the actual modeling will only take so much space in this whole proportion. So the machine learning application, as I already said, it will also have its own UI, its own server side of things. It will have a database logics. It will have a logging logics. It will have monitoring and other things. So what are all the machine learning application will be contains of? We can see here. This was proposed like 10 years ago by what all the hidden depth of a machine learning model. So everyone, when we started learning, even I also only learned the machine learning coding part, with pandas, sklearn. We will see in our demo. But there are lot many infrastructure or lot many things to actually look upon or care upon. So we will have monitoring that will that is a whole different league. We will have to monitor multiple items. The server infrastructure, machine learning resource management. So where this machine learning is running, all the compute management it will have to do. Analysis tools, data verification, data collection, the configuration manager, and the feature extraction and proposal management tools. So yeah, entire project life cycle will have to deal with or will have to address all this infrastructure requirements. So that is what we are going to see. So in a traditional or in a very simple ML model, ML project life cycle, we will have 4 stages. We will have scoping, we will have data collection, we will have modeling, and then we will have deployment. So all the things that we've seen in the previous slide, along with it, we'll also have some process oriented things. So this is scoping of the project, and the data logic and how the data infrastructure is established, labeling, organizing data, and a baseline performance, a first baseline performance. And we'll also again train multiple models, and we will pick the best model based on the error analysis. So I will explain you more during the demo, and development of model server and deployment in production. So all this infrastructure will be taken care or should be taken care by during the deployment phase. So without this project life cycle, we couldn't actually perform any or develop any machine learning application in our enterprise or any customer facing industries. So ML project life cycle, yeah, this is a descriptive of all the things that we looked before, but so the core things that we need to see here is these two things. So the modeling will deal on the research side of things, and the deployment will deal with the software engineering side of things. So with both research and the software development side of things, we can actually create a machine learning application. So this will mainly focus on creating a baseline model and running a lot of experiments and finding the best model. This will focus on how to package that developed model and pull to or push to the actual use case, or how to apply this model to the actual use case. So now we get to the topic of MLOps. MLOps is mainly actually proposed to bind all these three items together, or propose some framework so that all this all these four phases in a project life cycle is being addressed. So this is actually inspired from the word DevOps, which is developer operations that we follow in a traditional software system. How we can effectively reduce the development fee to the deployment phase. That is what DevOps will incur with. The same that is applied to MLOps is streamlining all the process of taking a machine learning model to the end level usage, maintaining them and monitoring them all in one flow. So this aims to bridge the gap between the research and the development part in any machine learning application. So MLOps also deals with the most important topic of automation. So everything that we are deploying, it should be automated end to end. So this is a very advanced or the first step into MLOps automation workflow. We can read through is better. So it all starts from the it will be all in a cycler flow, but we can always start from this side. So the first we will have some data that will have to go through data validation, preparation, model training, the evaluation, and model validation. So that will become our source code. Once we are done with our model analysis, validation, and everything, we will get that model as a source code that will go into the repository. So that will start our pipeline. So the deployment process flow. So the first process will come to this pipeline, which will again reach the production tool. Okay. And here, once the initial repository or initial model validation repository has been come in, it will train from the actual production data that is we are getting from the metadata store and the actual production data, and this model that we sent through will be trained on all the such data, and it will reach the model registry. So this model registry is where that will be used as our prediction service that will go into the deployment workflow, and it will go to the prediction service. So this prediction service is our application. In a ChatGPT's workflow, this will be the LLM. In our workflow, this will be the computer vision model that will say if it is a cracked image or a good surface. Yeah, so this is a very simplified portion. So this is all for experimentation. After experimentation, what will happen in the production? So this will be a constant cyclic, this will be an iterative workflow both the experimentation and the production will always be updating. So meaning if there is any problem here, which in the production cycle that we see here, it will be monitored and it will be triggered back into the research and experimentation. So if they see any drift, or if they see any concept drift or data drift, they will again go to the end pipeline. They will again do all the validation, preparation, model analysis, and they will again bring us a new source code. So that will be again used to retrain all the model and provide a new prediction service which is updated. So yeah, so this is the overall automation flow that we have seen. So what about the deployment and the monitoring? As I said, this will be the software engineering side of things. So developing a ML model is only halfway done. The rest of the other way is on the engineering side only. So deploying is a process encapsulating the ML model and the software to enable the users to utilize the model. So without actually deploying your model end to end, it is not of any use. Whatever research effort that you put into, whatever model analysis that you did, it is not of any use until you solve that actual problem with the use of ML as a complete end-to-end system. So, the common deployment causes are new product, automate and assist an existing expert manual with a manual task, or replace entirely of a previous ML system. So there are three kinds of deployment patterns, which is shadow deployment, canary deployment, and blue-green deployment. So this will all discuss about how much of a replacement that we are doing with the AI application. So a shadow application, shadow deployment will be a kind of deployment. There will be a human that will already be doing it, but this ML will also give them some insight to it. So example of this shadow deployment is in a healthcare sector. Say there is a doctor who is already diagnosing whether you have whether someone is having a diabetes or not. They are diagnosing for some disease. Uh, yeah, along with the doctor, we can also deploy a AML software which can also give you predictions on whether it is a disease positive or a negative. Obviously, it will not be used for the end level decision making, but it will be a extra help to the doctor or a physician. So second part is a canary deployment. So here you will have some this will use for the this will be used for the end level decision making, but only a portion of things. So only 10% of people will use this AML based model. Rest of the 90% will be using the existing software pattern or existing decision making pattern that is existing. So a blue-green deployment will be, you will have two kinds of ML model. So some people will be using blue version of the deployment, or some people will be using green version of deployment. We will take feedback from everyone who it is using, and we will find the best of the model in this two blue and green deployment. So yeah, so as I said all these things, this is the degree of automation that we have. So first is human only, meaning you will only have human-based decision. Second is shadow mode, with the example that I said with the doctor and the AI model. And third is the AI assistant, whereas here you will validate your value the output of a AI to build any software system or to do any decision making. This will be an example of chat GPT that coders are now using it. And partial automation is a way you will automate 10% of things or 20% of something that is completely being done by AI. And full automation is completely automating, completely removing the human in the picture and replacing them with the AI or ML system. Yeah, so for all this, monitoring and getting the actual feedback is very important. So that is why monitoring in both research side and the deployment side is very important. So this will give all the statistics on each and individual components to actually analyze where it is going wrong, where our AML application is going wrong or getting wrong. So monitoring can be all in all these aspects in a AML system. So first thing is software metrics. So this is traditional. This is all the hardware and software related inputs. The input metric is actually ML specific. All how the particular input is looking. If it is a tabular model, it will be a tabular statistical input variance, and if it is a image or a computer vision oriented metric, it will be the length, volume, and missing values or image brightness or whatnot. So we will have to monitor all this image brightness that we are getting from the users, so that if there is any data drift, we can actually identify and update our model subsequently. And number of uh, number of time our model is returning null. So whenever our model is not able to predict anything, it will return null, or how many times a user is retrying to get a new output from our model. That will also be a good indicator for us. So if you are using any Google voice search or even chat gpt, sometimes you will be trying an extra time, so that you will be wanting a different picture. So that will mean that on the first try you are not getting the correct input that you expected. So that's why you are retrying, so that you can get a actual output. So this sort of event tells that people are not happy with our model, our first version of our answer, so that they are retrying to get another version of the same answer. So this is a way of users indicating that our model is going a little bad. So such sort of things we'll have to monitor it and save it in some sort of database that will give us insight into how to update the model, how to address that issue. So these are all some practices that we follow in industrial projects. So for each application, the way of recording all this monitoring metrics will be different. But this is the overall gist of it, or idea of why we are doing this. And yeah, so it's just like how our ML research is an iterative process. You will straight away do not reach the ideal solution in the first try itself. You will have to see the feedback, find out what is not working, and you will have to backtrack it and change the inputs of the model. You will also do the same with the yeah, model deployment as well. So whenever we are running anything, all this with all this monitoring, all the systems, we'll have to capture all the edge cases. We'll also capture all this failure cases. We will have to do the analysis, performance analysis of how our ML model is performing. And we will also again have to do the development and the deployment of the same model. And we will also again have to calculate how much traffic. So traffic and time. So the end users are the real judge of your application. So not the data that you have. You may be trying or training some ML model on the basis of data that you currently have, but that is not the judge of how much accurate is the model. So on the real world environment and the real people who are using it, their call is the final call. And that's why we always put all this monitoring systems, and again we will also retrain all this process. So this is why a monitoring tool and the deployment, all this MLOps processes is being very crucial for our in our machine learning project. Okay, so one of the monitoring tool is ML flow. So this is being proposed, or it was being developed by the guys at Databricks. This is to simplify the research side of process, and for the ML practitioners who are developing all these models, this will be a good application to tracking model saving registry, sorry, model registry, evaluation, and managing multiple projects and recipes, which is nothing but code. So in this life cycle, ML development life cycle, I'm talking on the research side of part. You will have first training your model. You will again do a parameter tuning. Again, you will do a evaluation of all this process. You will have to have keep a track of all this experiments so that you will arrive at a correct ML model and the correct hyperparameter, so that you will be able to use the best model in your final deployment. So ML flow supports all this tracking, hyperparameter tuning, management, evaluation, validation, and everything. And it will also act as a model registry so that you can save all your ML models upfront, and you can get all the insights into the overall workflow. So this is to enable all the researchers to aptly finding out what sort of ML model that should be doing. So usually in any coding project or in any ML project, you will train a lot of you will try out a lot of different ideas and different things. But if you don't have a solid tracking tool, you will lose the context on what is the important, or which solution or which method was working out the best in terms of anything, but especially in for this context in terms of ML deployment. So that's why, yeah, a data set that you will have to have is a validation database, and you will validate on a test database that you will be having. So all this evaluation, hyperparameter tuning of all the different models, or on all the different settings and ideas, you will have to track it. So traditionally, I think some people, or even myself, I was using Excel or any spreadsheet application for all this tracking and doing. So this the way of using an Excel or any spreadsheet application to do this experimental tracking was being burdensome, as there is no one-to-one connection between this data that I stored in Excel and the code. So if there is a solution which will integrate into the code for doing all this sort of tracking and do this complete workflow, that will greatly enable that. So that's why we are having ML flow into our mix. So ML flow experiment tracking UI will be looking like this. I will show you in the demo. I will show you much more explicitly. So here you will have two sort of uh, categories: experiments and also models. So in experiments, you can have multiple sort of experiments. This can be your projects. This can be your within a project. You will have multiple different experimentation ideas. You can create different experiments for each of the sort of experiments that you do, and you can carry out all the different runs that you do internally in experiments. So you will also have you can also save all the models that you are generating, and you can find out in that models directory. So yeah, so in ML with with the ML flow, all the ML ops side of things will be covered. So earlierly, we would have seen what are all the things that we will do in a complete end-to-end project. And as we are focusing just on the research and development side, sorry, yeah. So these are all the application, and these are all the roles that are mapped into it in our industry or in any sort of enterprises. This will all the process that we will go through. So first is a data preparation. We will do some analysis on the data, and we will feature engineering and model training. So as a data engineer, I'm currently working on these two items in my current project. So the data engineering, this is to do with how to bring in all the data that will be used for machine learning operations or machine learning application. So we will have to work on a lot of pipelines or workflows which will map where we are getting the data and where we are storing and how we are storing the data. So the data that we should be prepared in a way that it should be easily consumable by all this machine learning development. So that's the job of a data engineer, and I'm being one there right now. And then from there, a data scientist will take care, and they will be sort of a research people in our project. So they will take this all these things, and then they will also work on, yeah. So they will work on analyzing future engineer. Sorry, I'm getting an echo. Can I mute it? Hope it is clear now. Yeah. On the explanatory front, they will take all this data, do some analysis, and find out initial insights. What all the data that will be useful for doing the data, sorry, doing the data modeling or machine learning modeling. And using those insights, they might create some new data streams. Using an existing data, we can also create some new streams which will give a even more understanding or even more context to the machine learning models that will be used by it in when it is and when we are training it. So the fourth step, or the third step, is data scientist will also train the initial piece of model. So for all this mission, we will have the support in ML flow to track this out, to model it, and monitor it every time so that we can find the best model to use on the things. So once they are developed it, they will give the source code or the model to the ML engineer. They will again do the last piece of validation, and they will have to work on the deployment pipeline settings. And they will, as a part of the pipeline, they will also set up the monitoring also. So this is what we seen in the earlier, the MLOps full workflow. So it will be a job of a machine learning engineer to map out all these things. And the business stakeholder will be a sort of client side of people. This stakeholder is the one that is responsible or accountable in using this model in the end level or application level. So they will take the validation, see if the machine learning model is performing it up to the mark or not, and they will give the green light to for our usage or approval. So overseeing all these different items will be our data governance officer. A data governance officer will be responsible for how the data is being manipulated or handled in each and every workflow, in each and every phase of this whole ML project. How is the data being handled? How is the data being is it handled all to the compliance? If it is having any piracy concerns, if the ML model is leaking the data to some other places, all these things will be monitored or keep in very high oversight by this data governance officer. So this is all the personalities that is involved in a ML project that will that I'd like to share. And this sort of all this different personalities come together in creating an automated system that will be a ever running a cycle of a loop that will be taken, and that will be solving any real life issue with the AI or ML. So yeah, so this is being our entire workflow that we currently follow in industries, and I hope that is in line with the latest and greatest that all the other countries and the governments follow as well when it comes to AI. So I have those resources, but before resource sharing, I will give a hands-on overview. Yeah, so you can see I opened the Jupyter notebook in my VS Code, and these are all some basic AML code that I'm using scikit-learn or sklearn to train a very simple model which can detect or classify diabetes. So we are going to see how ML flow will be useful for us. So to install, I hope you already worked with the scikit-learn and NumPy. It is easy as it only needs. Okay, let me clear it. And yeah, I opened the terminal here, and it is as easy as doing a pip install scikit-learn as things. And for ML flow, again, pip install ML flow will be the instruction. I will share this code on all these instructions later for you to look upon and refer this in the future. So yeah, so once we install an ML flow, we can start a ML flow UI using this command ML flow space UI. So once we did that, you will see this URL link listening at this URL. If you right click control and if you click on it, yeah, you can see this ML flow UI in your browser. This is my browser, and you will see two items in the ML flow. So I've already run an experiment and I already saved some model, but for you it will be mostly empty with the default experiment alone. So here you can see all the different items in ML flow UI, and let's go back to the code. As I already said, this is a very simple model that we are going to train, or very simple ML model that we are going to train. So as you can see, I'm importing all this ML flow and ML flow scikit variants and all those different models like random forest, logistic regression, and the metrics to evaluate. And I'm using the default data set that has been given by scikit-learn. So scikit-learn will have a lot of data sets apart from it, like iris data set, wine data set, and some digit database and breast cancer database. So of which I'm using diabetes data frame, just not a computer vision problem. This diabetes database, I will show you how it is looking like later. Uh, so first you will have to set the tracking URL, the one that, uh, so when we started the ML flow UI, you will get this address, right? You will have to copy this address and you will have to paste this. By default, it will be localhost 5000 only with the HTTP prefix, and you can set your own name or own designated name for your experiment. So this name can be different whenever you are running any new experiment. So for this experiment, this is my only experiment for this demo. Uh, but if you're working in a project that you are doing a lot of different idea implementation or experiment, you can do that way. So here you can set a name for it. So the same name will be appearing in the ML flows experiment tab. Okay, so first you're importing all the things. Let me restart and start afresh, clear all the outputs. So you're importing all the things and you are setting this tracking URL and the experimentation name. And here you are loading the data, and the data will be looking a tabular data which, for which you have all the outputs. So let me show this in a pandas data frame. Yeah, so this is our this is what our data set is looking like. This is all input data. So as you can see, this is a structure columnar format, which will have a multiple input variables or information about any patient and all their information here. So so through which you can get the source and target of your data. So our source is X is going to be all this input, which is data, and Y is going to be our target. So we are converting this into binary classification, meaning yeah, if it is if the prediction is above a median, we are calling it the same. So only if you print the X, or if you print the, sorry, so if you see the Y, it will just going to have 0 or 1. So it is going to be a binary classification problem. 0 means the patient, the particular input corresponds to not or no diabetes. 1 means it is a diabetes. So yeah, that's what we are going to go into, and we are creating the train and test set. As I already said, first we need to have a validation and test set so that we can do an evaluation later. So we are going to train multiple models, and we are going to see what all the metrics that, or what all the how that model is performing with respect to the different items. So we are going to train split it. So we will have X train, Y train, and X text and Y test. So we are taking 20% of the data as a test data, as the data as in the X and Y, our initial data. So as a part of model training, first we'll have to standardize all the data so that if it is not in a normal distribution, we will make it into a normal distribution through a standard scaling or normalization formula. So for that, we can import from sklearn. We have this pre-processing step. This is a standard scaler or normalizer. We can use that, and we can change the input X text train and X test so that it will be in smaller numbers as this, and it will be correctly distributed form. So this will make our model training and the performance of our model little better. So here in this dictionary, I am defining what all the models and what all the uh, model names, and then the models class. So this model class I'm importing from sklearn, you can see here. So all these are imported, and I am created the model uh, for this model term. So this I'm creating that in a dictionary so that I can run this in a automated way.
సర్ఫెక్సల్ లేకపోతే ఇంకో బ్రాండ్ తీసుకో.
Cool.
సరే 2
So
ప్యాకెట్స్ ఉన్నాయి కదా,
this,
తర్వాత మళ్ళీ ఇంకో వీక్ వెళ్ళి తెచ్చుకుందాం.
yeah,
అప్పుడు
can you
తెచ్చుకోవచ్చులే స్టీల్
mute,
కూడా.
please? Someone mute. Okay,
సరే సార్.
this is our core training and evaluation
మిగతాయి మళ్ళీ
code.
వెళ్దాంలే. మళ్ళీ
So this
ఎప్పుడైనా
here
ఊరికి
we are
వెళ్ళినప్పుడు
initializing all these variables as a null or a zero, and this is our for loop. This for loop will take this for loop will take this dictionary, and for each model, it will use the same training and evaluation code to train all these three models. So we are going to train the model using this code. So since we are using scikit-learn, this interface is same for everyone. Every model will have a fit and every model will have a predict function. So with that, we can train and get the predictions. So using that predictions and the actual data, we can have an actual Y output and the predicted Y output to get all this evaluation uh, metrics. So accuracy, precision, recall, and F1. These are all classification models, evaluation metrics with which we can figure out which is the best data model. So here is our experimentation logging is coming into. So with YAML flow, using this YAML flow dot log param, we can pass in what model name it is, and we can also log how much accuracy, how much precision, and how much recall that I am getting. Each metrics or evaluation metrics and any hyperparameters, we can log it here. And finally, all the saved log or saved model will have to be logged using this model. So I trained all this model. Now I need to save it somewhere so that all this will be saved somewhere. So I'm using mlflow sklearn dot logging the model. Here logging means tracking or traceability. Here I am giving the model's URI and registered model to see it in the thing. So after running this, I will, sorry, yeah, after running this training pipeline, so this will iterate and save every model like this. So first it ran the random forest, and now it is running gradient boosting. So every model, it is saving it to ML flow. So if you go to the ML flow and you come to our experimentation, you can see it. There are a lot of runs that is run. So we'll see the recent 3 runs. These are all the models that we train. So we have 3 models, and we can see 3 runs here, which are happened very recently now that we run it. So the run name will always have some randomized name. So inside it, if we go to any one run, we can see the parameter being saved here. So in this code, we are logging the parameter, right? Model type, model name. So the model type is a random forest. We recorded that. And the metric is how much the random forest has been performed, we can see here. So these are all the how much the random forest has been taken. And if we go to the second run, we can see gradient boosting model type and all the evaluation metrics of the gradient boosting. And similarly for the last one, this is ADA boost, and in ADA boost, we can see all the metrics here. And similarly, you can see the registered models also. We are registering the models here in this line, logging the model. So we are saving the model in ML flow itself, so that in the future, I don't have to run this same code again to use this model. I can just come to ML flow and see this ADA Boost model, and I can download it and see the information about it. So when it is time, when I am done with this, I can add or promote this model into a new model called as this is my production ADA Boost model, or production diabetes prediction, you can call it. Okay, so if I had decided that I'm going with the EDA 4 version 4, I can name it as a new thing and then I can save it. So now there will be a new model called production diabetes prediction model that will be created. So I can share this production diabetes model to the next set of people or ML engineers or a business use case. So they will take this model and then they will do the validation and the deployment using this. So in this models flow, you can see all the saved models and the versions of it. So the last part of our code is tracking the best model. We are always, during the training itself, we are trying to see which model is having the best F1 score. So based on the F1 score, we are saving the model and we are tagging the model as the best model. So we already have a best model here. We have two versions of it. So if you come here, you can see the source run is coming from this particular logger. And you can see all the artifacts here. This will give how to run this model in a complete workflow. So you can just use this code in any of your prediction engine. You can take it. Yeah, so this will download in the this will get downloaded and we can use this model anywhere. So here all the predictions from this model. So this is the simplicity of ML flow and how it will give us or store all this both the experimentation and the actual model and the actual ML engineering and research. So yeah, so so these are the use cases of ML flow. In very simple terms, if I'm going to run some different experimentation now, I can set a new experimentation here, and imagine I'm changing all these estimators here. So 80, 70, and 30. So I can also log all these estimators as well, but let's go with this first. Okay, so we are logging an extra parameter as well in log param n estimators. So model dot. Okay, so I changed this estimators. I'm running a new experiment now. You can see this is running as a new experiment. And if you refresh the screen, you can see the new experiment, ML flow diabetes experiment. We can see all this new items. And you can also see we have added a extra parameters called n estimators 80. So since this is all a random forest method, all this are random forest or boosted random forest, we can add estimators. So if you're training some other neural networks or some other RNN or LLM models, you can use this log param as any sort of key, and then you can log the parameters in it. So if you are changing this estimators value, you can also see how this matrix is differing. So if you need to see which is having the best one, or if you need to choose what all the models that are coming with more than 7, you can see F1 score greater than 7, you can select this and we can filter like this. So you can see the F1 score for this item or for gradient boosting is greater than uh, 0.7. So we can filter all these items using this experiment filtering mechanism. So, yep. So that's all from my demo. Do you have any questions on the code or any conceptual side? You can ask now.
Dear participants, if you are having any doubts, you can kindly post now.
Yeah, I'm happy to share all these resources and some future technologies. So apart from MLflow, we all have other technologies as well, which are much more advanced. But it is good to look into and get some idea on how this AutoML and how this MLOps is being implemented by all these different state-of-the-art companies like Google, H2, Hugging Face. These are all some leading pioneer companies that are in AML. And the first link and also this QR code will let you know all the resources that I have developed over the years. This will give you some starting point in AML, MLOps, and engineering as well. So you can access those full list of resources.
Yes, I request the participants, if you have any queries, you can unmute yourself and ask, or you can post it in the chat. Yes, okay.
Sir, Arun sir. Sir, what are
Yeah.
the cloud resources we required, sir, to run this any ML experiment in ML flow?
So to run any statistical based or a very simple ML models
Yes, sir.
like the one that I showed you in the demo, like
Regression
random
analysis or
forest, gradient
classification.
boosting,
Yes, sir.
linear
Yes.
regression. So all these things will not need such big resource. You can run it in your own laptop or any computers.
Yes.
And for the ML flow also, you can run it at your own computers only. But for deep learning purposes, for running any large language models, deep CNN models, RCNN models, LSTM models, based on the size of the model, you may need to run it in a big infrastructure. Obviously, Collab is a very good resource.
Yes.
Kaggle also is
CPU.
a good resource to
Yes.
run all this at free of cost.
Yes, sir. Thank you, sir.
Thank you.
Questions from any other participants?
Sir, it is cloud is necessary, sir. Cloud computing is necessary for this developing an application, sir.
Um, yeah, development of an application, for that we don't need cloud, but deployment of such application we will need cloud, because without cloud or without any infrastructure, you cannot reach out to the end users. Say you are developing an ML application, you want that to be deployed or used by multiple people across geographies. You will have to seek cloud for as a support to your AML infrastructure. But edge computing that I said, right? Everything will be running in your own machine itself. That one you can develop and also distribute locally. But that will only applicable for smaller ML models, not a bigger ML models.
Thank you, sir. Thank you so much.
Uh, and a point to press on is when we are going into or chasing this AML trend and other cryptocurrency, all this trend, always only that field is getting all the front face value. But I'm here to say in using this in actual all our ML projects, all the basics and fundamentals of computer science and software engineering that we learned till now is being a helping aid or being a critical component in all this ML project. So that was my point to make in this session. Not only ML is being important in any project, all this cloud technologies, all the fundamentals of Python and distributed computing and networking concepts, all this will be equally demanding in is being demanding in our projects that at that time part of now.
I think no. Is anyone else here for doubts? Participants, if there is anything, you can ask.
Madam, can you please share the PPTs, madam, once the
Yeah,
session was completed?
sir, sure, sir. The video is getting recorded, sir. We will share the resources with you once the end of all the
Thank
6
you.
day session, sir.
Okay, madam. Thank you so much.
Yeah, thank you, sir.
Today's session was so nice, sir. Thank you so much for giving this this type of knowledge.
Thank you, sir.
Thank you, Arun, sir.
Thanks for inviting, sir. It's been a delight.
Yes. So, in this occasion, I would like to conclude this session with the vote of thanks. First of all, I would like to thank Mr. Arun Pandian, Senior Data Engineer, Siemens, for his valuable time at this time, especially at the evening time at the end of his day. He's spending with us. Thank you so much, Mr. Arun. And thank you so much for sharing such a real time AI development methods which we haven't worked with so far, being an academician. So thank you so much for your insights. And I also would like to hope for the future connections with us so that your knowledge can be shared with us. And I'm really happy that you are sharing your works with us because not everyone can share that. It is really a great pleasure for us. Those who are really interested can make use of your resources, Mr. Arun, and it is really a helpful thing. Thank you so much. I would also like to thank all the participants for patiently waiting and uh, listening that video and asking the doubts, and thank you for that. So once again, I thank each and every one of you, those who present here, and once again, thank you, Arun. Thank you so much. Thank you all.
Thank you,
So
ma'am.
thank you, Arun. So link will be shared for the feedback, so you can fill it. Thank you, participants. Thank you.
Thank you, everyone. Have a good evening. Bye.
Just wait for 2 minutes, participants. The link will be shared in WhatsApp also. There seems some problem. Just 2 minutes.